Good morning. Today we're on lesson 2, distributions. We're going to spend 2 days on this topic because I want to make sure I give you everything that you would need. The first thing is on this packet that they give us a histogram, and you might recall from middle school that histograms are continuous bar graphs. They don't have breaks unless there's no data for that interval. So if you look here, this first bar is going from 80 to 85 and then 85 to 90. It's continuous. And that makes it the difference between being a plain old bar graph, and that is why we call it a histogram. Up here, this is relative frequency, which goes back to what we were doing with the probability. These are percents. So this is not a number, this is a percent. So if we look at this histogram below, it's the distribution of battery life for a sample of 40 batteries of the same brand. When studying a distribution, it's important to think about the shape and the spread of the data. And that's basically what we talk about with distributions, is the spread of our data, how it is looking. Is it a normal spread? Is it a non-normal spread? So when we look at this first exercise 1, when it says that, would you describe the distribution of battery life as approximately symmetric or skewed? Here, this would look like it is approximately symmetric. It's approximately symmetric because if you were going to draw a histogram that you're used to seeing, it would go up, it would have height, and then it would come down, and that would be what we would call our normal bell curve. Now, this isn't perfectly underneath the normal bell curve, but this is approximately symmetric. So that's how I would answer this question here. Oops. And is the battery life distribution closer to 95, 105, or 115 hours? Well, if you look at this, it appears to be centered, even though this is a really bad normal curve that I'm drawing, it appears to be centered around 105. And it looks as if roughly half the data is to the left of 105, and about the other half would be to the right of 105. So is the mean, and again, the mean is the average. Now, whenever you take an average of something, you add everything up and divide by that number, and that mean gives you the center. So an average is actually finding the center of your data. And we have a symbol for mean now, and it looks like this. It's an X with a bar on top. And this is the symbol, and we're going to show it on the calculator. But this mean does look to center around 105. So if I were to, and let's change the color. Let's make this prettier. All right. So here, the mean looks to be centered at 105. It looks as if half the data is to the left and the other half, the data to the right. Okay. So now we get to example 3. Consider 5, 10, or 25 hours as an estimate of the standard deviation of the battery life. Is it a reasonable description of a typical distance from the mean? So if you look, like I was saying before, it looks as if these bars are in steps of 5. 105 to 100, 100 to 95, 95 to 90, and the same the other way. It looks like we're going +5 and +5 and +5. So A, is it reasonable description of a typical? It looks to me, according to this graph, to be a reasonable description. So it looks to be a reasonable description of the standard deviation Now, standard deviation is something we're really going to have to go into. Standard means, when something is a standard, it's what you go by, and the deviation is how we're spreading out. So this standard deviation of 5 looks to be very, very reasonable. The part B, consider 10 hours as an estimate of the standard deviation. Is it a reasonable description of a typical distance from the mean? It looks as if you could use 10, since here, if we were, and let me use a different color, if we were counting by tens, you would have 2 bars in each one of these. And we're going to go into this very soon, but 10 is also a really good description because, it looks as if 2 bars could really be one spread of the data, or 5 could have been a spread of the data. So 5 or 10 look reasonable. The third one they're asking about is 25. 25, not reasonable at all. So according to the way this data was given to us. So it does look reasonable for the standard deviation to be 10. Now, the next thing is consider 25. Is 25 reasonable? No. No. 25 is not a reasonable spread of this data. It's too big. It doesn't seem to make sense compared to the picture they gave us. So let's take a look at this guy here. This guy here says this is a histogram of the distribution of the greatest drop in feet for 55 major roller coasters in the U.S. All right, so maybe you're a roller coaster junkie and you travel the U.S. and this roller coaster, this bar here, you're dropping between 50 and 90 feet. This one, you're dropping between 90 and 130, 130 and 70. Notice the spread is 40. So we have a spread of 40 right here. And this is definitely not a normal curve. This curve, if we take a look at it, this curve went way up and then it has a tail over here on the right side. So this has a tail. And if it has a tail on one side, we call that skew. So this guy, because it has a tail on the right, we would say this graph is skewed to the right. And so that's actually what number 4 is asking. Would you describe the distribution of this roller coaster as approximately symmetric or skewed? This is skewed. This is absolutely not a normal curve. And it's skewed to the right because it has a tail on the right. The data is not centered. Is the mean of the maximum drop of this distribution closer to 90, 130, or 240? It would probably be closer to the 135. 90 looks to be too small because it's too far over to the left. And the 240 is too far over to the right. It's in the tail. So 135 would probably, if I had to make a guess, being that I don't have the data list, since here's 130, and I had to make a guess on where the mean would be. The mean looks to be around 135 because 90 is too far to the left and 240 is too far to the right. So, I mean, right now we're just looking at these pictures and we're analyzing what we would think. Number 6, is the standard deviation of the maximum drop closer to 40, 70, or 100 hours? Excuse me. Well, like I said, each bar looks to be about a length of 40. But if you're looking at the standard deviation and you're looking at around the 135, which actually I'm going to move this little bar over a little, so this would be around 135. If you went 40 on each side from here, it just doesn't look big enough to be a good standard. But if you went here and here, that looks to be a much better spread of the data from this center. So if I had to answer this question, I would absolutely be saying 70 looks to be about the typical spread. $40 looks too small, and 100 looks too big. So let's take a picture now with these down here. We have these 4 histograms. And what they're asking us to do is consider the following histograms. We have 1, 2, 3, and 4. And they have descriptions given, and they want us to match the description of the distribution with the approximate histogram. This might be a good time to pause the video and try it yourself and see what you think. You know, histogram 1, 2, 3, and 4, looking at the picture, which one do you think would be A, shaped skewed to the right, B, approximately symmetric mound, C, approximately symmetric mound shaped, but you have a standard deviation of 40, and skewed to the right with a standard deviation of 40. So give it a shot, see which way you think it goes, and then turn the video back on and see if your work will match mine. Now, I'm thinking that histogram 1 matches B. because histogram 1 is approximately symmetric, like you can see that you have a nice center there, and it looks like your standard deviation is around 10. Based upon the height of the bars, that looks like what you would be. Number 2, to me, looks like it would be A. And it looks like it would be A because we are absolutely skewed to the right. We can see the tail off on the right, but it does look like the bars that we have are about 10 apart. With standard deviation of 10 definitely looks good to me. Number 3, I would go with C, approximately symmetrical, but look at the spread of the data. So a standard deviation of 40 looks like it works. And then finally, number 4, we only have D, but it is definitely skewed to the right and the spread of the data is much bigger, so the 40 would work. And hopefully you did that on your own and you checked yourself, and if there's a question, you'll contact me and let me know. Let's take a look at 8. The histogram below shows the distribution of gasoline tax per gallon for 50 states and the District of Columbia in 2010. So they actually went and found this data, so this is true data. Describe the shape, center, and spread. So now what we want you to do is try to analyze this a little. Now, when I'm taking a look at this, to me, if I got to find the dead center, which I told you, the mean is going to be in the dead center. What an awful line. This looks like the mean is right here. There's my center. When I look at that center, that tells me my mean is 25. So if I had to write out what I'm thinking here, to me, the mean is 25. So there's my center. Now, the shape of this, if I were to see, well, let me try to follow along. This, to me, looks like it's normal. This looks like a normal shape to me. Well, maybe not too normal. It looks like it's mostly normal and a little skewed to the right. So that's what I'll put down. The shape looks somewhat normal, a little skew to the right. And then the spread, when I look at this, the spread looks maybe, I would say a good spread here would be 10. 5 might be a little too small. It looks to me like a good spread for this would be 10. So the spread, I would say, for this one looks to be 10. 5 looks a little too small. So see what you think about number 9. Again, you should always try to take, turn the video off and try it yourself. Now, when I look at number 9, you definitely see the center somewhere here around 89. So I'm going to draw that in. So here's my center. To me, whoa, again, I can't do a straight line with the mouse for my life. My center looks at 89. So my mean to me looks to me around 89. My shape, even though this is missing some, and these are high and these kind of are lower, if you think about it, these bars probably fit this height. Now these heights are the same. And this missing bar here probably could come from these bars. So me, I'm thinking this is probably close to normal, not too normal, but it looks approximately normal. So this shape would be, to me, approximately normal. And the spread of this data, when I'm looking at these numbers and I'm trying to think about the spread, it looks like this would probably have a spread of 10 just like the other one, because if I were to go this way, this looks like where I would be about the same, and to me that looks like a spread of 10 if I had to pick a nice round number. So the spread of this looks to be around 10 also. So right now, these aren't perfect. These are just looking and trying to get a feel for the shape and the spread of data. So when you are looking at these kinds of problems, there's a summary here about looking at, like this would be an approximately normal spread, and it's a nice mound. And here, you know, you're down here, you're skewed to the right, and here you're skewed to the left, because this is where you would have your tails. So the mean distribution is interpreted as a typical value, and the average of the data values make up the distribution. A standard deviation is a value that describes a typical distance from the mean. Now we're going to find really a standard deviation very soon. And hopefully it'll make a lot more sense after you just spend a little bit of time just like looking at things and thinking through what you would have. Now, the next item that I'd like you to try to do with turning off the video would be problem 3 of the problem set. All these problems I'm going to ask you to do, you know, for homework tonight, 1 and 2, but let's take a look at problem 3. Problem 3 is asking you to go back to 9th grade, and you might have done this back in 9th grade, and you remember it, or maybe your teachers didn't do it. I really don't know how it went. But if you are looking at this data and you have a number line, a dot plot, oops, in the wrong thing. A dot plot is when you actually make a dot for each piece of data. Like for 380. 380 is somewhere before 400. So I'm going to put a dot right here. And then I have 790. Well, 790 is almost 800. So right now, turn off the video until you are done making this, and then turn it back on. And check your work against my work. Okay, so here I ended up making my little dots for each piece of data. And you want to make sure that you don't cross off your data. Notice when I did the beginning with you, I just put a dot above the data I used, because you always definitely want to look back. Now, if you look at your dots, most of your dots are centered around the center. So even though you have a bunch of dots here that might go higher, if you think about it, most of these are spread out evenly, except for this one tiny little spot. So if you had to describe the shape of this calorie distribution, this would be approximately symmetric, because it, you know, was mostly spread out in an even way. Using technology, find the mean. Well, this is where we have to start with the calculator. If you're going to find the mean, what you need to do is get the calculator. Come on. All right. Here we go. And I have to teach you a couple of things. Now, we already know how to use the list. We've used the list before. So everybody, second memory for clear your lists. And then you have to hit stat and edit. You're back in your lists now. And what you need to do is you need to put in all of this data that they gave us. So you might want to pause the video and you might want to get that data put in for yourself. So 380, 790, 680, 460, 725, 1130, 240. And make sure you are not typing anything in wrong. You got to look at your numbers and double check your numbers. So you put in 32 pieces of data, and notice at the bottom, it should say 33 with nothing typed in. And you should absolutely go back up and check to make sure that you did not type anything in wrong, because the minute you have even one digit off, your data is not going to come out right. So you check all the way up to the top, and you make sure you don't have anything crazy typed in. All right. And now what you're going to do is you're going to hit stat, calculate, and you're going to go into number one, variable statistics. Now it's very important you go into number one. And you hit enter and enter. Now here's the mean. Just like earlier in the video I told you, the mean has an X bar on top. And if we look at our work, it says find the mean and standard deviation. Now they didn't tell us how to round. So I'm just going to say, let me come over here and type that in so this way everybody can put it on their paper. Let's round to the nearest integer. Let's just go no decimals for right now. So if I do that, I have this X, and I'll put the bar on top, is equal to 665. So calories for these hamburgers, 665 would be the average calorie. Now here's the thing, they ask you for the standard deviation. Now they want the actual standard deviation. Now look back at your calculator. This is the mean. This here means the sum. When you added up all the pieces of data, there's that sum symbol again that we used back in chapter 6. And this here, this SX, is a sample standard deviation, and this is the population standard deviation. Now, when they just ask you for a blanket standard deviation, they're asking you for a population standard deviation, because what we did is we used the entire population of data that they gave us. And the standard deviation on this would be 279. Now on this one, they say find the mean and the standard deviation. So the standard deviation on this would be 279. If they said a sample standard deviation, we would have went with 283. But here, the standard deviation is 279. And let me just see if they have the symbols. All right. All right, so I got to do this. And where is the symbol for standard deviation? No. Here it is. So the standard deviation is equal to 279. And this standard deviation symbol, you'll notice, looks like a script O. On the calculator, they try to, it looks like a script O as well. And again, if they just say standard deviation like they did, this means the population standard deviation. And the population means you found the standard deviation of all the data. A sample standard deviation, you took a sampling of the data, and we're going to go into that a little bit more later on. And the bottom line here is, why do you think there's a lot of variability in the calories? All right, well, you know what? This tiny little 380, I could tell you right now, that's the calorie count in a McDonald's tiny little burger they put in the Happy Meal. Most of us do not get that burger. You get to 1180, this is like the Applebee's Cowboy Burger, which is absolutely delicious, but I mean, look at the calorie count. So the reason why there is such a high variability, because look at how these numbers vary. There's very high variability, and that's because it really depends upon where you go and, you know, what size burger you get. So answers vary. I'm not going to type that all out. Also, it matters, you know, did you put fried onion rings on top, or did you just put ketchup? So, you know, there's a big, big difference in what you're going to get based upon what's on your burger. So, all right, so today I want you to do the homework section yourself, the problem set, and let me know if you're having any trouble. Good luck.